Hello guys, in this video we will be discussing about inverse function. Our main objective is to solve for an inverse function. But before that, our primary assumption is that in solving for our inverse function, make sure that the function is a one-to-one function. Now for example, if I have here f of x is equal to 3x plus 2. This function is a linear function because our x variable bears an exponent of 1. So expect that your graph is in the form of a straight line. Now first thing to do is to determine, is this function a one-to-one function? By definition, one-to-one function, a graph of a function is the graph of a one-to-one function if any horizontal line intersects the graph at no more than one point. So first thing to do is to determine if this is a one-to-one function. So we are going to do the graphing of this linear function. How to do the graphing? In my case, we will be using table of values. Now we know that f of x is just equal to y. So we have here our x, y. So we can pick negative values, 0, and we can take positive values. Now you can proceed with negative 3, negative 4, negative 5. You can proceed with 3, 4, 5. It depends to your preference. Now, if x is negative 2, all you have to do is to substitute your x with negative 2. So, for example, if we have here f of negative 2, because our x will be replaced with negative 2, and then copying 3, x times negative 2, and then copying 2. Simplifying, f of negative 2 will become negative 6 plus 2, which is now equal to negative 4. So our y is negative 4. Now if our x is negative 1, the same process, 3 times negative 1, that's negative 3 plus 2, it will become negative 1. If x is 0, substitute. So 3 times 0, 0 plus 2, that's 2. If x is 1, so 3 times 1, that's 3 plus 2, will be equal to 5. And when x is 2, 3 times 2, that's 6 plus 2, it will become 8. Now we have here our table of values that we are going to plot, okay, in our Cartesian plane. So let's do that. Now, assuming this is our Cartesian plane, now we have here values negative 1, negative 2, which is to the left of x equals 0, and we have here positive 1, positive 2, and you can continue with 3, 4 if you want. It depends on your set of ordered pairs. And then your y, we have here negative y values, negative 1, negative 2, negative 3, and then negative 4. We have here positive values like 1, 2, 3, 4, and you can proceed with 5, 6, 7, 8. Now, if x is negative 2, our y is negative 4. That's our first. This is our first ordered pair. So if x is negative 2, our y is negative 4, so somewhere here. Now, if x is negative 1, y is negative 1. If x is 0, then y is 2. If x is 1, then y is 5. So if x is 1, 1 is 5. So from here, if x is negative 1, y is negative 1. So we already plot that. Now if x is 0, y is 2. So if x is 0, y is 2. This is now the solid dot. If x is 1, then y is 5 from here. So if x is 1, y is 5. So we're going to plot that here. And you can actually continue to the right and continue here to the left. Which means to say that we're going to both an arrow both sides of the line, which means that's continuous going to the negative infinity and going to the positive infinity. Now we are going to connect the points. So that's going down. And then here, we're going to connect here. So expect that this is in the form of a straight line. And if you are going to draw any horizontal line on the graph, we call this one as a horizontal line test. It passes the graph at no more than 1 point. Okay, so this is our horizontal line test. Now, what's the purpose of the horizontal line test? Okay, its purpose is if ever the graph or the horizontal line passes the graph at no more than 1 point, then this function here, f of x equals 3x plus 2, is a one-to-one function. So therefore, f of x is a one-to-one function. One-to-one function. So that's one of the primary goal or assumption, that our function must be a one-to-one function so that we can find its inverse. So next is that we are going to solve for the inverse function of the given one-to-one function. Okay, the first step is that we are going to replace f of x with y. That's the first step in solving for the inverse function of a one-to-one function. So y is equal to 3x plus 2. So what we did is we replace f of x with y. Second step, we are going to interchange x and y. So y will become x and x will become y. Next, we are going to solve for y with respect to x. So we have to transpose to the left. So this will become x minus 2 is equal to 3y. And then if we will try to divide both sides with 3, so this is now cancelled. So y is equal to x minus 2 over 3. After solving for y, we are going to replace y with f to the negative 1 or f inverse. So they have here f of negative 1 of x is equal to x minus 2 over 3. Now, the inverse function of f of x equals 3x plus 2 is f inverse of x is equal to x minus 2 over 3. But wait, we have to verify if our f function and f inverse are really inverses to each other. How to do that? Now, first thing to do is that we are going to satisfy that f composite of f inverse of x and the second one, f inverse composite of f of x are having the same result. So from here, this is composite function. So what is f composite of f inverse of x? This is now f of f inverse of x. This is our first case in verification. Now here we have f, copy the f. But what is f inverse of x? X minus 2 over 3. So substitute f inverse of x with x minus 2 over 3. So this is now x minus 2 over 3. Okay, next thing to do is that we are going to substitute this value to the x of the function f of x. So replacing x with x minus 2 over 3, this will become 3. Replace x with x minus 2 over 3, so we have x minus 2 over 3, and then plus 2. So from here, we're going to cancel that. So what's left is x minus 2 plus 2. But what is negative 2 plus 2? That is 0. So in short, what's left is x. So f composite of f inverse of x is just x. Now, on the second case, make sure that the result is also x so that we could say that the original function and the f inverse function are really inverses to each other. Meaning to say their graph are mirror images with each other. So what is f inverse composite of f of x? This is now f inverse of f of x. So this is now equal to, copy f inverse. But what is f of x? F of x is equal to 3x plus 2. So we have here 3x plus 2. Now this is now the x value that we are going to substitute on our x in terms of f inverse because we are dealing now with f inverse. So we're going to do that. Continuation here. So x will be replaced with 3x plus 2. This will become 3x plus 2 minus 2 over 3. So replacing x with 3x plus 2, but we have still another term, negative 2, copy over 3. What is 2 minus 2? 2 minus 2 is just 0. So we have here 3x over 3. So this is now being cancelled or 0. So what's left? 3x over 3 cancel 3 over 3. What's left is x. Are they having the same result, x? Yes. Therefore, the original function f and f inverse are really inverses to each other. So this is really the inverse function of the function 3x plus 2. If you will try to do the graph of 3x plus 2 and x minus 2 over 3, they are really mirror images to each other. Thank you for watching.